Good everyone, my name is Graphics. Today we want to study a very important aspect of mechanical engineering science, which is also an aspect of what? Of physics, applied physics, where we'll be studying motion, but the part of motion we'll be studying about will be what? Velocity time graph. So it is an aspect of representing the motion on a graph, right? We have the velocity time graph, we have the displacement time graph, we have the acceleration time graph. All these are graphical method of what? Representing motion. Now, when you talk about velocity time graph, it is a graphical method or graphical way at which we look for what? For the distance displacement of an object, right? We look for the velocity of an object, and we also look for the acceleration of an object. Now, we know very well that we said motion is the change in the position of a body with respect to time. So we are going to be plotting velocity against time. So if you're seeing something like this, you're going to be seeing something like this, whereby the x-axis will be given for the time, represent the time, which is in what? In seconds, right? And y-axis is for the velocity, which is in what? Meter per seconds, right? Now, the slope of a velocity time graph always signify the acceleration. For instance, now let's assume a body is accelerating, right? A body is what? Accelerating. This is how you represent a body accelerating from an initial position of what? 0. So this is the axis of velocity, and this is the axis of what? Of the time. The slope of a velocity time graph is the acceleration, right? So when you say a body accelerates, we're talking about change in velocity with respect to time. Now look at this. Let's assume that at this point here, let's say we are given as what? T1. And at this point here, let's say we are given as what? V1. Are we good? At this point here, let's say it is what? T2. And at this point here, let's say it is what? V2. Now if I should draw the slope, this is the slope here. Are we good? This is the slope here. So we say the slope of this graph here, this inclined part here this is change in what? V. Or we'll call it, or you say it is what? dV. Right? Y here is what? The change in t. Or you say it is what? You say it is what? dt. Now if you look at it, whenever you are having dV over what? dt, it means that what? Final velocity minus initial velocity all over the time minus what? The initial time. And this is nothing else than what? Acceleration. So instead of we using V2, we are going to use V for our final. So we're using V1, we are going to use U for our initial. And instead of we using T2 minus T1, we just simply use what? Our T, right? And this is what we call our acceleration. So the inclined part of velocity time graph is the acceleration, which is also called the V over the T. Now another thing you need to understand about your velocity time graph is this. We know this is our T, which is its unit is what? In seconds. And we know this is our V, which is in what? Meter per seconds. Now if you see a line coming this way, if you see a line coming constant, as this way, you say velocity is what? Constant. Right? In this case, our acceleration is what? Is equals to what? 0. When it's a straight line like this, you say what? Velocity is what? Constant. So acceleration is what? Is 0. Is that taken? Now, another thing you need to understand again is when you have this way. When you have this way, whenever it is coming down this way. It says it is what? It is decelerating or it is retardating. And deceleration is negative acceleration. Deceleration is what? Negative acceleration. Is that taken? Deceleration is what? Negative acceleration. So when it is coming down, you say the body is what? Decelerating. When it is on a straight line this way, you say it is what? The velocity is what? Constant. Here acceleration, you call it negative acceleration, or you call it deceleration, or you call it retardation. Now let's see. But one thing you need to know, that the slope, the acceleration here is decreasing, right? Here the acceleration here is 0 because of what? The velocity is what? Constant. Here the acceleration is what? Is increasing. As long as it is a velocity time graph, the inclined points here are always acceleration. Now let's just take an example and see how we are going to apply this. Look at this question. It says that a car starts from rest and accelerates uniformly until it reaches a velocity of 30 meters per second after 5 seconds. It maintains this velocity reach for 15 seconds and is brought to rest in 10 seconds with a uniform retardation. Determine A, the acceleration of the car, B, the retardation, C, the distance covered in 5 seconds, D, the total distance covered, E, the average velocity over the whole period. Now, if you watch my previous video, you get to understand what we are talking about when you talk about motion. But for now, let's now see how we are going to analyze this. When you say a car starts from rest and you are representing your information on a velocity time graph, you know you are plotting a graph of velocity against time, right? That means the velocity is on the y-axis and the time is on the x-axis, just like this. So I'm going to have this way. Now this is the x-axis, which is to represent our time, which is measured in seconds, and the y-axis, which is our velocity, which is measured in what? Meter per seconds. Now it says the body, what did it say happen to the body? It says a car starts from rest and accelerates uniformly. This is my hand here. It accelerates what? Uniformly. So since it's accelerating, we're talking about a velocity time graph, right? Your acceleration will start from this point, let's say our 0 here, at rest, and it will start accelerating this way, to start going up this way. Can you see that? So it shows that what? It is accelerating uniformly until it reaches the velocity of what? 30 meters per second. You say it accelerates uniformly until it reaches the velocity of what? 30 meters per second. So that means at this point here, the velocity is what? 30. Right? Since I placed my meter per second here, so I don't have to write it here anymore. For 5 seconds. So I'm going to trace this down, my dotted line. For what? For 5 seconds. That is how you represent that. Now, also, it says that it maintains the velocity reach. So that means it is constant now at this particular velocity for 15 seconds. So it maintains it from this point. It maintains it. So you use a straight line to show that what is maintaining it. That means they call it the velocity here is constant. So at this point here, all the velocity at this point, both initial and final, is what? Is 30. How good? So the time it spent in maintaining this velocity is what? 15. So you are going to add 15 and 5. So you'll be having what? 20 seconds. Is that okay? Now also, we also have that and is brought to rest in 10 seconds with uniform retardation. So when you say retardation, that means it is decelerating. It's coming down. It's brought to rest. Back to this point here. For what? For 10 seconds. So what you do, you're going to add 10 to 20 and you're going to be having 30 here, right? So now from this point here, in 10 seconds with uniform retardation, determine the acceleration of the car. So we want to know the acceleration of the car, and this is when the car is what? Accelerating. One thing you need to know, that where it is starting from, it is what? U. Where it is ending is what? V, right? So we know very well that my acceleration is what? The rate of change of velocity with respect to what? Time. So it means that my acceleration is equals to what? The v, change in velocity, over what? Over what? The t, which is the same thing by saying v minus u all over what? All over t, where we know our v is the final velocity, our u is the initial velocity, and our t is what? Is the time. So what we simply do here, we will now say that my acceleration will now give me v. What is v? The final velocity. You start from 0 initial to v final, that will be 30, right? Minus the initial, which is what? 0, all over the time. The initial time is 0, the final time is, so we have 5 here. So in the long run, we say that what? My acceleration will be equals to what? 30 all over what? 5, which will give me what? 6 meter per second square, which is the unit of acceleration. So the acceleration of the car in the first 5 seconds is 6 meter per second square. So this is solution number A that we just did now. Now solution number B, we are told that the retardation of the car. I told you the retardation means what? Deceleration, which is what? Negative acceleration. So since here is u and here is v, right? So if you are doing for retardation, here will be u and here will be what? V, because you are retardating starting from here. So this is the starting point and this is the ending point, right? So for the question B here, what we simply do, we will just say that my acceleration here is equals to what? V minus u over t. That's acceleration, right? But in this case, what is my v? My final velocity v is when the body is coming to rest, the car is coming to rest. So that our v is what? 0. Minus my u is when the body starts to come to rest. So and that from the body starts from 30 meter per second before it comes to rest. So my u is what? Is 30. So we have what? 30 all over the t, which is also what? So the t here will be 20 minus 30, and that will be what? That will be what? 20, that will be 10. So we have my 10 here. Then my a, which is acceleration, will now give me minus 30 all over what? All over 10, which will give me minus what? 3 meter per second square. So the negative here is telling us that what? The body is what? Decelerating. The acceleration is what? Decreasing. Right? So that is the B. Then for the C here that we say that the distance covered in the first 5 seconds. Now there is a secret here for the question C. When you are calculating distance in a velocity time graph, it means that what? You are going to be looking for the area. I'm going to be multiplying the velocity and what? The time. Are you with me now? So what we'll do here, in this case here now, this is, we're having a figure this way, which is this. We're having a figure this way, right? And the height here is 30 and the base here is 5. So this is what we're having. The height is 30, where we say the height here is the v and the base here is the t. So we say t here is equals to 5 and v here is equals to what? 30. And the area is called the displacement. The area of the plane figure of the triangle of the velocity time graph is also called what? The displacement. So we say our displacement x, right, is equals to half base, our base represented by what? T, times what? Times the height, which is what? V. So this will now give us half times t is 5 times 30, which is our v. So 2 we go in 30. How many times? We have 15 times. Then 15 times 5, that will going to give us 75. Right, so we're having 75 meters. So the displacement or the distance covered in the first 5 seconds is given as what? 75 meters. Now if you look at it again, we are told to calculate the total distance traveled. Now the total distance traveled here is the addition of the distance in each stages. Now we say the first stage 0 to 5 is stage A, 5 to 20 is stage B, 20 to 30 is what? Stage C. So our distance x, the total distance st, is equal to what? The distance at stage A plus the distance at stage B plus the distance at stage C, or we say the displacement, right? So from here we already know that at stage A, let's just do that. At stage A we are having this. So the distance at stage A, look at stage A, we already calculated for it, which is here x. So we are going to simply put xa is equals to what? 75 meters. That is at stage A. We just did it here. Now the next one will be the distance at what? At stage B. So at stage B, if you look at stage B, what figure do you see at stage B? That is what? A rectangle. So I'm going to have a rectangle here, which is something like this. Right? V is the height and T is the time. So we say that distance is the area of the rectangle, which is what? The length. Length here is the time T, times the width or the height, which is what? V. So my s, which is the distance, will now give me what is t. T will give me 20 minus 5, that is 15. So we'll say 15 times the v, which is constant, and that is what? The v is 30. So we'll now say 15 times 30 will give us 450 meters. That is at stage B. So similarly, at stage C, the distance at stage C, we know is also rectangle, right? So we're going to have this way, a triangle. So we're having this way. If you look at it very well, this is the shape here. At stage C is forming a triangle. So we know that this is T, this is V, and the area is the distance, which is equal to what? Half base. The base here is T times height, which is what? V, right? So my x here will give me 1/2 multiplied by the T, which is the base, is 30 times 20, 30 minus 20, and that is what? 10, multiplied by the V, which is constant, that is 30. So 2 in 10 is 5. 5 times 30 is 150. So x here is what? 100 and what? Is it 150? So we have yes, 150. That will be 150 meters. That is the distance at stage C. So we'll say that therefore my S total will be the distance of distance at stage A, which is what, 75, plus distance at stage B, which is what, 450. This is what we have here, which is 450, plus distance at stage C, which is what, 150. So the total distance traveled is what, 6, that will be 600 and what, 75 meters. That is the total distance of the car in that seconds, in 30 seconds, right? Now the next thing here that we are trying to accomplish here is that we're now told to calculate what, the average velocity over the period. Now I said it earlier, before now, that my average velocity VAV, average velocity, is equals to what, the total distance traveled, ST, total distance traveled, all over what, the total time taken, that is my T, right? The total what, time taken. Would I just say T subscript T, the total time taken? Let me put it that way. Now, what is the total distance traveled? We don't calculate for it, and that is 600 and what, 75, all over the total time taken, which is what, 30. So if you divide 675 by 30, we will be having 675 by 30 will be 22.5. So we'll be having 22.5 meters. So that is for that question. This is example 1. So we're looking at another example 2. Now if you look at this, it says the body starts from rest and accelerates at 3 meters per second square for 4 seconds. Its velocity remains constant at a maximum value reached, so for 7 seconds. It finally comes to rest with uniform retardation after another 5 seconds. Find by graphical method the total distance moved during each stage and the average velocity over the whole period. So since this is a graphical way of representing it, the first thing you first of all draw, you draw your velocity against time. So this is your T for seconds and your V for meter per seconds, right? So since you said the body starts from rest, you know you draw your inclined line. How good? And what happened to the body? And the body accelerates at 3 meters per second square for 4 seconds. So we know very well that our velocity here is not given, right? But the time is given to be what? 4 seconds. So we know that it accelerates. Acceleration A is equals to what? 3 meters per second square, and the time is given as what? 4 seconds, right? 4 seconds. Now what you simply do here is this. We know very well that our initial velocity here, u, is equals to what? 0, right? And our final velocity v is what we don't know. That is why I am placing my v here. We are looking for the v. So from what we did earlier, we said that acceleration is equals to what? Change in velocity over what? Change in time, which is something as saying v minus u over t, where v is final velocity, u is initial velocity, and t is what? The time. So my acceleration we know is 3 meters per second square, equals to velocity that we know, we don't know it, final velocity we don't know, minus initial velocity is 0 because the body is starting from rest. So we have 0 all over the time in 4 seconds. So if I cross multiply, 3 times 4 is 12. So we say that my velocity is equals to what? 12 meters per second. So I'm going to put this equals to what? 12 here. So my velocity there is 12. So let's proceed. Now in proceeding, we say that for 3 meters per second in 4 seconds, its velocity remains constant. So the velocity continue it remains constant at the maximum value reached for 7 seconds. So it maintained that 12 meters per second for another 7 seconds. So for another what? 7 seconds. So 7 plus 4 is 11. So that means at this point here, we have what? 11. Now, let's move forward. It finally comes to rest with uniform retardation. It's decelerating for after 5 seconds. So it's coming to rest back to this point for what? 5 seconds. So 5 plus 11, that is what? 16. So this is what we have. So we are now told to calculate what? Using graphical method, the total distance moved during each stage. So the first, when it's accelerating, is stage 1. When it is constant, it is stage B, and when it is decelerating is what? Stage C. So we have 3 different stages. So just like I explained earlier, so we can just start. It's just the same as the previous example, but in this case we are given acceleration of velocity. So you have to convert from acceleration to velocity for you to be able to work with it. Now from here, what you simply do here is this. You're going to write, recall the total displacement or total distance t is equal to what? The distance traveled at stage A, which is when it's accelerating, plus the distance traveled at stage B, that is when the velocity is what? Constant, right? Plus the distance traveled at stage C, that is when it is retardating, it's decelerating, right? So that is our total distance. So let's start to do that. So what you do here, you're going to write that distance traveled at stage A. So we know stage A is giving me a triangle, an angle triangle, which is something like this, alright, whereby the vertical part here is given as the V, the horizontal part here is what? The time axis. So the V here is the vertical, which is 12. If you look at it, the V is 12 and the T here is 4. So we know that the area of a triangle is the displacement. So the area of a triangle is the what? The distance traveled, which is equal to what? Half base times height. Half, what is the base? Is T. Then what is the height? The height is V. So move forward and say that my 1 over 2 multiply by 4 times 12. So 2 can go in 4 is 2. 2 times 12 is what? 24. So my distance traveled at stage A is equals to what? 24 meters. 24 what? Meters. That is at what? Stage A. Now, if we move forward, the next one will be what? At stage B. So let's just do it here. So we say that distance, let us put distance traveled at what? Stage what? Stage B. At stage B, what do you notice? We are having a rectangle. So if I show you that we have this rectangle this way, right? The base here or the length here is T, and that is giving us what? 4 minus 11, that will give me 7. The height still remain the same. Velocity is giving us what? 12, because velocity is constant here, 12. So we say that the area is the distance, and that will give me the length, which is T, times the height, which is V. So we now say that T is 7 multiplied by 12. So we say 7 times 12, that will give me 84, right? That will give me 84. So SB XB is equal to what? 84 meters, because distance is measured in what? Meters. Now the last but not the least, we say the distance at stage C. So at stage C, let's do that and see. We have similar thing. At stage what? Stage C. We have this, right? It's decelerating at stage C. The time axis here, 16 minus 11, that is 5. And the height is still V, which is what? 12. So know the area of a triangle is half, that is XB. XC is equal to half T times V, base times height. So 1 over 2, what is the T? The T is 5, multiplied by the V is 12. So 2 here, 1 in 12, 6. 6 times 5 is 30. So the distance traveled during stage C is equal to what? 30 meters, right? So we say that therefore the total distance traveled is equal to what? The distance at stage A, which is what? 24, plus the distance at stage B, if you look at it very well, plus the distance at stage B, which is equal to what? 84, plus the distance at stage C, which is what? 30. So that will give us 138 meters. So that's our what? Total distance. 138 meters, that's our total distance. Now the next thing here, which is what? The average velocity over the whole period. So it's as simple as this. The average velocity VAV is equal to what? The total distance traveled, right? The total distance traveled over the total time taken. Are we good? So what is the total distance traveled? That is ST, which is 138, over what? The total time taken. The total time here is given as what? 16. So 138 over 16, right? So all over 16. So when you divide this, 138 divided by 16 will give us 8.625 meter per second. So our average velocity is 8.625. So that is for that question. Now the third example is this. Now it said a body at rest is given an initial uniform acceleration of 8.0 meter per second square. So what you simply do here, since it is a graphical method of representing motion, you are going to draw your velocity against time, right? So if you look at it very well, it says the body at rest. So we are accelerating at this point. The body at rest is given an initial uniform acceleration of 8 meter per second square. So at this point, we don't know the velocity, but we know something for sure, that our u is equals to what? 0. Our v is unknown. Our area is equals to what? 8.0 meter per second square. Then the t is 30 seconds. So for what? For 30 seconds. So I write my t here. This point is 0, right? So if you recall that my acceleration is equals to what? Change in velocity over what? Our change in time, which is given as what? V minus u over t, where v is final velocity, u is initial, and t is the time. So the acceleration here will now give us, the v here is unknown. The acceleration is what? 8, right? V is unknown, minus the u is what? 0, all over the t is 30. So if I could multiply 30 times 8 will give me 240 meter per second, is equals to what? V. So the V here is what? 240 meter per second. So I'll put my V here to be what? 240. Now we move forward, after which the acceleration is reduced to 5 meter per second. Don't get confused. We are not told that it decelerated. We only say the acceleration is what? Reduced. So that means instead of it going straight, it's just a little bit bent down. It is what? It is reduced to what? 5 meter per second square. So the next guy here is 5 meter per second square. So we'll do the same thing. That if you look at it, for how many seconds? For 20 seconds. So at this point here, we have 20 seconds. 20 times plus 30 is what? 50. Right? So we need to convert that guy. So if you look at it, this is U and this is what? V. So my U in this case here, my U is equals to 240. My V, let's move forward. My V is unknown. Initial, this is initial, this is final. But if I'm considering this part here, this will be initial and this is what? Final. So my initial here is 240. My V is what we are looking for. Then the T is giving us what? 20 meter per second. 30, 50 minus 30 is 20. And the acceleration is what? 5.0 meter per second square. So if you do the same thing by saying your acceleration, A is equals to change in V over what? The T, which will give me V minus U all over T. So acceleration is 5. The V is 200, is unknown, right? And the U is 240 all over the T, which is what? 20. So if I cross multiply, 20 times 5 is 100 minus V, no, equals to V minus 240. So if I take 240 to this side, we'll be having 340 because the minus will turn to plus. You add it to the 100, we're having 340 meter per second, and that is what? Our V. So at this spot here, our V is what? 340 meter per second, right? So now for the next 20 seconds, now the body maintains this speed. So this body it maintains this 340 meter per second, right? It maintains this speed 340 meter per second. Maintain the speed for what? The body maintain the speed attained for 60 seconds. So 60 plus 50, that is 110. So at this point here, we're having 110, right? So you add it to this. After which, it is what? After which it is brought to rest. After which it is brought to rest in 20 seconds. So after which is brought to rest for what? 20 seconds. Then it is not brought to rest. So that is, it is decelerating. Brought to rest. So at this point here, we are bringing it down for 20 seconds. So 110 plus 20 is 130, right? For 20 seconds. Then that's what you draw. So this is our velocity time graph here. This is what we have. So we have 4 stages. Stage A, stage B, stage C, and what? Stage D. So what is the question that is being given here? The question here is that we should calculate the maximum speed attained during the motion. We all know what the maximum speed is. The maximum speed attained during the motion is 340. That is the maximum speed. So you can just easily write it that our maximum speed attained is equal to what? 340 meter per second. Now the next thing here that we're looking at is average retardation as the body is being brought to rest, or average retardation as, or we say the retardation as the body is being brought to rest. So if you look at the retardation, that is the deceleration. This is what we have, is coming to what? To rest. So this is the question A. Then the question B, you know, this is the retardation. Let's calculate for what? The retardation, right? When it's brought to rest. Now we have this way. That's like what we've been doing since morning. So from here, this is T, which is equals to 130, and that will give you 20, and the height V is what? 340. So my V here is equals to what? 340 in this case. So if you apply your retardation, talking about the deceleration, right? So our retardation here is given as A is equals to what? The V over what? The T, which is V minus U all over what? T. Now what is the V? Now since we are considering this axis here, this slope here, this, you say that this is our initial and this is our final. So the initial here U is what? 340. The initial is what? 340, sorry. Then the final is what? 0. So 0 minus 340 all over what? The T will be this minus this, and that will be what? 20. So my retardation A is equals to what? Minus 340 all over what? 20. So what is 340 divided by 20? 340 divided by 20 will be 17. So acceleration will be minus 17 meter per second square. So the negative is telling us that what? It is decelerating, right? So the next thing that we are told to do here is that the total distance traveled during the first 50 seconds. The total distance traveled during the first what? 50 seconds. So what you just simply do here, the first 50 seconds is what? So I'll just put it that my S50, the total distance traveled during the first 50 seconds. So that will give me, I can write my distance traveled in the first 50 seconds is equals to what? The distance traveled at stage A plus what? The distance traveled at stage B. Why did I choose that? This is the major reason why I say that. The first one is from 0 to 50, and that means both stage A and stage B. Is that okay? So I will come here and write during stage A. So we have distance traveled during stage A, right? So we see that we're having something like this. Look at this, stage A is forming a triangle. So I'll come here, I'm going to put it that way. So my triangle is something like this, right? So the T here is given as 30, and the V here is given as what? 240. So you check that very well. The T here is 0 to 30, and the V here is what? 240. So we'll move forward. So we know that the area is the distance. So SA is equals to what? Half times T times V, and that will give me 1 over 2 times 30 times 240. That will give me 2 in 30 is 15. 15 times 240, that will give us 3,600. So 3,600 meters. So that is the stage A, right? So if we are to look for stage B, let me just do it here. For stage B, it will be, we have more something like this. It looks like a trapezium here, right? So we're having this shape here. We're having this shape here. So we have something like this, right? So in this case, the high point here is 340, here is 240. I'll call it u. Initial velocity is this, and this is what? Final velocity. Then the height, the base here is t, right? And that is 30 minus 50, that is 20. So what you do here, we say that the distance traveled at stage B is equals to what? Initial plus final all over 2 multiplied by what? By t, which is the time. So what is the initial? The initial u is 240 plus the final is 340 all over 2 multiplied by what? Multiplied by time, which is what? 20. So from here we will say that 240 plus 340 is 780. 780, no, that would be 680. 680 multiplied by 20 divided by 2 give us 6,800. 6,800 meters. Alright, that is the distance covered at stage B. So we now say that my x distance in the first 50 seconds is equals to SA, which is what? 3,600 plus XB, which is 6,800, and that will give us plus 3,600 plus we have 3,600 plus 6,800, and that will give me 10,400. 10,400 meters. So that is the distance covered in the first 50 seconds. Sorry, this is 5,800 because 240 plus 340 is 580 times 20 divided by 2 give you 5,800. So this will be 5,800 here, right? So 5,800 plus 3,600, and that'll give me 9,400. So my value here is what? 9,400 meters. Then the last but not the least, we say the average speed during the same interval. So the average speed during the same interval. What is the interval? The same interval, 50 seconds. So we say that my average speed is equals to what? The distance traveled at 50 seconds, which is the same interval, all over what? The time taken, t, at also what? 50 seconds. So that will give us 9,400 all over what? 50. So that will be what? Divided by 50. That is 9,400. Sorry. 9,400 divided by 50. So that will give us 188 meter per second. 188 meter per second. So that is the what? The average velocity during the same interval. So if this video was helpful, don't forget to click on the subscribe button. Thank you for watching.